Kendall, that's a nice book. Why are you writing in the margins?
Oh, I figured Fermat did it, so why can't I?
Good point.
You heard that story?
I have. Why don't you tell me about it?
Sure. Well, Fermat, way back in the 1600s, was studying number patterns and really interesting equations. And he came up with a cool conjecture. And he wrote his conjecture in the margin of a book, and he also wrote that he found a proof, but there wasn't enough room in the margin to write the proof.
Right. It's called Fermat's last theorem.
That's right. So for 300 years, mathematicians worked on that theorem. You know, they tried, they explored it, they learned a lot of stuff along the way, but nobody could prove it until the 1990s.
Right, Andrew Wiles.
Exactly.
Right, so just to go over a little bit about the theorem, you might be familiar with the Pythagorean theorem, where we have a squared plus b squared equals c squared, where a and b are legs of a right triangle and c is the hypotenuse. And there are many solutions to this. In fact, here's an example. If you took 3 squared plus 4 squared equals 5 squared, that is a true equation. Now, what Fermat conjectured, and what Andrew Wiles later proved, is if we raised the power higher than 2, a positive integer higher than 2, like 3 for example, that there are no possible positive integers you can choose for a, b, and c that would make it true. And this would work if it was 3, 4, or 5 as the exponents.
Cool. Well, you know, I think there might be a challenge along these lines.
Right, so we have a similar challenge for you. So we want, right, another MathQuest challenge. What we want to know is, let's suppose I took a cubed plus b cubed plus c cubed. Is there a, b, and c and d positive integers where I can choose where it would make this true? And what we would like you to do is, if you can find positive integers a, b, c, and d, enter those in our contest. And you can either do that through a private message to our Facebook page or emailing it to us at contest.mathquest@gmail.com.
I bet we get some great solutions from this one.
We are, and there's more than one, so try and find those. Send those in.